But let me tell you a little bit about his background. He's known as the Human Calculator. That was a nickname given to him by television star Regis Philbin. He's an educator, speaker, Guinness World Record holder, best-selling author, host of the Human Calculator TV show on the History Channel International. He's been teaching mental math shortcuts and entertaining people around the world on television with his superhuman skills for more than 28 years. He earned his nickname as a result of his remarkable abilities to perform rapid mathematical calculations, including addition, subtraction, multiplication, square roots, cube roots, with amazing speed, and calculator accuracy using only the power of his mind. Scott is a multi-award winning Guinness World Record holder for the fastest human calculator, which includes correctly adding a randomly selected two-digit number, 38, to itself 36 times in 15 seconds without the use of a calculator. Faster than a person could do that on a calculator. According to a recent scientific study, his mental calculations are faster than his ability to speak the answers. So please, warm welcome for keynote speaker, Scott Flansburgh.
Hi everybody, how you doing? Good. Just by show of hands, who likes math? Who hates math? Okay, good to know where you're at. Steve, thanks for the introduction. It's an honor to be here today. Thanks for sticking around this afternoon. I know a lot of you had a chance to get in your car and disappear, so thank you for giving me this bit of time. I'm working on something very exciting and interesting, and I hope you find it to be the same. So I'm called the Human Calculator, but I have to prove that. So I have a calculator here, and one of my buddies is here. Jeff, come on up, buddy. Jeff's lives in Phoenix. He runs a marketing company, has a STEM program. You can tell him a little bit about it after we get done doing this. Okay. All right, but he's going to run the calculator for me, and I got to warm up my brain. Okay, so everybody hear me okay over here? Yep. Okay. Yeah. So I need somebody with a loud voice that can pick some random numbers for me that he'll do on the calculator, and I'm going to do in my head. Who'd like to volunteer? Anybody? Just I saw somebody. Yeah. Okay. What's your name?
Suresh.
Okay. Let's do some addition first. Okay. So. When I was in 3rd grade, our teacher taught us how to add, and I figured out an easier way to do it. So I'm going to demonstrate it for you, and then I'm going to teach you how to do it. But first, let's start out with some addition. I'm going to come down here because I can still see the screen, and I don't want you to think I'm cheating. So let's start out with some two-digit numbers, like 89, 47, whatever you want. I'll say plus between each number you say. Jeff's going to add them up on the calculator, and I'm going to try to add them up in my head. So let's just get a nice rhythm going, okay? So I'll close my eyes so that I can't see anything. The calculator's at 0. Okay, go ahead. First number?
39.
39. Plus?
47.
47. Plus?
21.
What was that?
21.
Plus?
52.
Plus?
37.
Plus?
88.
One more.
91.
375. Okay, oh, Jeff is right there too. All right, good job. Now, thank you. I'm just curious, how many of you could add up a column of two-digit numbers in your head with no pencil and paper? Nobody's raising your hand, but I disagree. I think everybody in the room can do it. Before we leave today, you will be able to do it in your head. But I'm still warming up. Let's get somebody else to pick some numbers. Who else raised their hand? I saw somebody. Come on.
I'll do it for you, Scott.
There you go. Thank you. All right, we played golf together yesterday, so let's use those numbers to memorize. All right.
It must be really big numbers.
There's a C there.
It's different.
Yeah, it's different. Okay. It's got a mission there. Okay, you ready? Let's do some multiplication. All right. So I want you to pick two-digit numbers, and I'll multiply them in my head. All right, we'll do it on there. So go ahead.
97.
97 times 18 is 1,746. All right, okay. Try another one. I'm still warming up. It's all right.
Okay. 41.
41 times
73.
2993. Yeah. Okay. All right. Now I'm tuned in, and I want to let's do one more fun one. Let's do some division. All right.
Okay.
So pick like a 3-digit number,
Okay.
and divide it by a 1-digit number, and use weird numbers so there's some decimals in the answer. See what I mean? Odds against evens or whatever. So a 3-digit divided by a 1-digit. Make it tough.
Okay. 973.
973 divided by
6.
162.1666666. Okay, all right, so now I'm warmed up. How many of you can do that? No, all right, no, I'm not going to tell you how to do that one. Okay, clear the calculator, Jeff. And I want to demonstrate for you my Guinness World Record. This has sort of got me to go around the world for the last 30 years. It's a dream come true. I have a gift for numbers, but I was in front of math class one day, and my buddy had a calculator, and it was one of the first years that calculators came out, and he noticed something weird about it. Go ahead and punch in 5 plus 5, Jeff, and hit equals, and it's going to say 10 up there on the bottom. But now hit equals again, and you'll see the calculator says 15. And so if it keeps hitting equals, it will keep counting by that number 5. So just get a nice rhythm going. And you can see the subtotals down there on the left. But a calculator, that's called a constant. And my buddy did that by mistake one day. He said, hey, what's 28 plus 28? And I said the answer, and he hit equals again by mistake, and it added 28 more. And he goes, well, hey, what's 28 more? And it's like something woke up in my head. And so I'm going to demonstrate that for you. So let's see, let's get somebody else. Would you pick a 2-digit number, please? Just shout it out.
56.
Thank you. 56 plus 56 equals. And you'll see, I'm just going to start counting by 56. And you'll see that my brain gets going faster and faster. Okay, ready, Jeff? Just sort of mirror me. Here we go. 112, 168, 224, 280, 336, 392, 448, 504, 560, 616, 672, 728, 784, 840, 896, 952, 1008, 1064, 1120, 1176, 1232, 288, 1344, 1400, 1456, 1522, 568, 164, 681, 732, 798, 1848, 1904. Where are you at, dude? Let's go. That's okay, buddy. So you can see that my brain gets going so fast, my mouth has a tough time keeping up with my brain. So that one, I did, I started off slow, then I went medium, then I go fast, then I go crazy. This time, I'm just going to go crazy and show you what it's like when I'm trying to set the Guinness World Record. So let's go to the calculator. Same guy, you did a great job, 2-digit number. I'll wait till you take a bite and then I ask you for the number.
97.
That's too close to 100. Anybody can do that.
Okay.
Maybe tough. 83, prime number, very good. So 83 plus 83 equals, and this time I'm going to go full speed. My world record is 15 seconds, so I'll go about that time. Ready, Jeff?
Sure.
166, Oh, right there, buddy. Hey, give Jeff a hand at least, all right? I got one more. Because you guys are all technical, smart people. I'm in the Guinness Book of World Records for this, and I do the show, and I beat the calculator, and they say, you're in the book, and they said, we got one problem. We think you're cheating at doing this. And I was like, well, how do you cheat counting by 83? And they said, well, we don't think you're actually calculating. We think you just memorized all these answers. And I said, that would be incredible to remember all those numbers and recall it that quickly. I said, but that's not how I do it. I am wired like a calculator. He said, well, can you prove to us that you're not memorizing these numbers? So you'll notice that a calculator always starts at 0. So starting at 0, counting by 83, I could have memorized those numbers. But what if instead of starting at 0, we started a totally random number, like 812, and now count by 83? There's no way I could have memorized counting by 83 from every number. So let's clear the calculator. Let's do 0. Good job, Jeff. That was fast. All right, one last time. Let's pick a 3-digit number that's our new 0 for this example.
767.
Ooh, that might be prime too. That's pretty impressive. 767. I'm going to be working on it right now. Plus, and I'll pick a 2-digit number you want me to count by, starting at 767.
76.
That's too easy because they're all the same. Yeah. Sorry, did you punch that in right quick?
No,
yeah,
no,
that's too simple. Jeff could have done it.
I would have gotten that.
Yeah. Okay, so what do we start at? 767 plus 51. Okay, ready to go, buddy? And I've never done this pattern before. You'll see I get going the same speed.
I'm hitting equal or plus? I'm sorry.
Equals. So you did 767 plus 51 equals, right? So you should have 818, 869, 920, 971, 1022, 1073, 1124, 1175, 1226, 1277, 1328, 1379, 1430. Same speed. I can just go, as soon as I ask my brain this math question, my brain is wired in a way that I can just get the answers as fast as humanly possible. One more demo, one last thing, just did this, and it's coming out next year, is I just set a new world record doing a 3-digit number. Nobody's broken my 2-digit record yet, but they're going to release this one. So let's clear the calculator. Would you pick a 3-digit number? Don't go, be gentle, not like, Massive.
273.
Well, good one. All right, so 273 plus 273. And nobody's seen this on TV yet. You guys just get a chance. I'm going to go about the same speed, 15 seconds or so. You ready, Jeff?
Yep.
273 you said, right?
Yeah.
It's okay, I got it. 546, 819, 1092, 1365, 1638, 1911, 2184, 2457, 2730, 3003, 3276, 3549, 3822, 495, 4368, 4641, 4914, 4914. One more. There you are. All right. Hey, thanks, Jeff. Great job. So that's why I'm called the Human Calculator. I have a sense for numbers. I can't fully explain it, but today I'm going to try and explain it to you a little bit. I'm on a mission. The first 20 years of my life was all about me as the Human Calculator. Look what I can do. In the last 10 years, it's sort of reinvented myself. It's not about me. It's about how can I help kids and teachers and parents. And when you ask better questions, you get better answers. And so I want to share with you today how I see numbers as a human calculator and see if it makes sense to you. My mission is to reach every kid around 9 years old to teach them this stuff. But let's just start with you guys and see how it goes. But everybody take a look at the calculator. And you have these on your phone. They're on our computers. They're everywhere. It's sort of creating atrophy in our mind. We don't use number crunching as much. We sort of use the calculators and just don't use numbers much more. So I just want to point out a couple things to you first. Everybody take a look at all the numbers in the yellowish area in the bottom. And how many numbers are there? There's 10 numbers, but there's no 10. But we are all wired to think like this since we were little kids. Your kids are doing it now. We have 10 fingers, and we all go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's cool if you need to count your fingers. But if you want to think like a calculator, there's no 10. It's really 0 through 9. And the only reason a calculator works is because it starts at 0. And we don't count 0. And so I've created a curriculum to help kids learn how 0 counts. So watch this, 10 fingers, 10 digits, and it goes like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how digits really work. It's 0 through 9. So everybody, please, if you don't mind, just for fun, take your hands, put them up in the air. Let's shake out that 1 through 10. The Romans did that to us. They're evil. Now close your fists, and let's all start with 0 on the first finger. Ready? Go.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
So now, you're all thinking like a calculator, so I can talk to you like a calculator for a minute. When I was a kid, this is the first thing I saw. I was in second grade. Our teacher wrote these shapes on the board, and she was going to start talking to us about numbers. And I stopped her and I said, "Excuse me, who picked those shapes? Why do numbers look like they do?" And our teacher didn't know the answer. So I started asking other teachers. They didn't know the answer. So I sort of made it my mission to find out why do numbers look like they do. And so, you can hear me okay, right? Okay, so here's what happened. The inventors of these shapes wanted each one of you to be able to figure out the value of each shape just by looking at it. And here's the secret behind it, was to count the corners. So look at 0. 0 is a circle. How many corners are there?
0.
That is why 0 is a circle. So when people looked at that shape and they counted 0 corners, they knew that shape had a value of 0. The number 1 started out like this, because this shape has 1 corner, 1 angle. So everybody knew that shape had a value of 1. The number 2 started out like our letter Z, because it has 2 corners, 2 angles. The number 3 started out a little more hieroglyphic looking, like that, but it gives you 1, 2, 3 angles, 3 corners. The number 4 was a little different font. It started out like this. That gives you 1, 2, 3, 4. There's the 4th one right there. 4 angles, 4 corners. The number 5 almost looked the same. They just put a tail on it. That gives you 1, 2, 3, 4, 5 corners. Everybody knew that was 5. It gets easier as they get bigger, believe it or not. 6, they just boxed it up. Looked like this. You got 1, 2, 3, 4, 5, 6 corners. So everybody knew that was 6. 7 was tricky because we draw it like that, but somebody really smart came up with that. That gives you 1, 2, 3, 4, 5, 6, 7 angles. So there's 7. 8, they just use the hourglass symbol, this symbol, and you count them right. 1, 2, 3, 4, 5, 6, 7, 8, the outside angles.
And then 9 got pretty weird looking. They actually called this the ugly duckling, but it got the job done. You got 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Have you ever seen that before? So when I show this, when I do shows at elementary schools and the 2nd, 3rd, 4th graders learn this, they are freaking out. They can't believe that they haven't been told this. And it sort of connects them to these shapes. It makes them feel like they have some super secret information or something, but it's just to get you started. So now you're all thinking 0 through 9. You know why they look like they do, but here's what happened. I'm just going to throw out some math problems. Just shout out the answer as fast as you can. What's 2 plus 2? 4. 7 plus 7? 14. 9 plus 9? 18. How are you guys all getting these answers so fast? All memory. Nobody's calculating anything. We don't teach our kids to calculate. We put them through a memory drill to make sure these kids know their math facts so they get the scores and the parents are happy, the teachers get paid. It's the simplest way to get it done, but there's really no foundation or number sense. So today I want to introduce you what I call Chapter 0. I believe this is the missing chapter in math, and if kids would learn this first, it would revolutionize their relationship with numbers and make it easier for our teachers to teach these kids math. So here's the difference. We did 0 through 9. 9 is the biggest number, but a lot of you haven't been doing any mental math. So I want to show you something about the number 9 as far as adding goes. If you don't know how to make 9 in addition, just do this. Start writing your digits, 0, 1, 2, 3, 4, and then keep going underneath backwards. 5, 6, 7, 8, 9. And if you notice, they all create equal 9. 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 7, 3 plus 6, 4 plus 5. Those are all the different ways to make 9. That's it. Those are the combinations that kids need to know to turn on the calculator in their head, because here's why. What is the biggest number on a calculator? 9. The secret to numbers is every number higher than 9 goes back to 9. I have to tell you the story behind this. I live in Phoenix. I was playing golf on 9/9/99, right before Y2K, when we were all going to die from the calendar. And so I invented a new calendar to fix it. It's a 13-month calendar. It's a zero-based calendar, and the New Times did a story in September of 1999. But I was on the golf course this day, and it was supposed to come out that morning. I was all excited about it, and I was playing golf with Alice Cooper. And we were on the 18th hole, and Alice says, "Hey, 18. I wrote a song called 18. 1 plus 8 is 9. Today's 9/9/99. How come 18 adds up to 9? I said, "Alice, that's easy. Any number times 9. The answer adds up to 9. 2 times 9 is 18. 3 times 9 is 27. 2 plus 7 is 9. 4 times 9 is 36. 3 plus 6 is 9. And he goes, "Okay, I don't care." And I'm driving home. And, yeah, he's the anti-math guy. And so I'm driving home thinking about this. And I got home and I looked at my 13-month calendar, and something happened. Look at number 13. Now just add up all those digits. What's 1 plus 3? 4. Put the total underneath and subtract. What's 13 take away 4? And it was 9. I was like, what the heck? What are the odds of that? That 13, if you just add up its digits and subtract it, it's 9. And I noticed this on 9/9/99, just after 9 o'clock in the morning. And it really sort of freaked me out. And a minute later, I saw the number 11. I tried it. 1 and 1 adds up to 2. Put the total underneath and subtract. 11 minus 2 is 9. I was like, what is going on? So I tried it with other numbers. 10. Add up the digits. 1 plus 0 is 1. Put the total underneath and subtract. 10 minus 1 is 9. This pattern works to infinity. Let's try 17. 1 plus 7 is 8. 17 minus 8 is 9. A little bit bigger number, 19. 1 plus 9 adds up to 10. Put it underneath and subtract. 19 minus 10 is 9. It gets crazier. 20. 2 plus 0 is a 2, so put the 2 underneath and subtract. 20 take away 2 is 18, but look at the answer, 18. What's 1 plus 8? 9. So today, when you guys are driving home from this wonderful event, Steve, great job, by the way. Lee, everybody, you guys, really great job. You guys are going to get on Highway 89. When you see 89 now, you got a chance to exercise this calculator in your head. What's 8 plus 9? 17. 89 minus 17 is 72. Look at the answer. What's 7 plus 2? 9. When you're driving home, you're going to see a speed limit sign that says 65. 6 plus 5 is 11. 65 take away 11 is 54. Look at the answer. 5 plus 4 is 9. Every number you see on the way home tonight, if you'll just do this simple exercise, you're going to be tapping into a part of your brain that we don't use. It's sort of gone into atrophy, but this is where number sense and calculation begins. So let's just try a couple random ones. Everybody try your age. all right? Think of your age, all right? Let's say you're 40. You write down your age. Now add up all the digits. 4 plus 0 is 4. Take it away, you get 36. 3 and 6 is 9. So everybody try your age and see if it works. Just give me a nod or something when you get it. Does it work for you? Is everybody getting their age to work? This works from every number from 10 to infinity. Let's try a big number like 93. 9 plus 3 is 12. 93 take away 12 is 81. 8 and 1 is 9. If you do a 3-digit number, 123. 1 plus 2 plus 3 is 6. Take it away, you get 117. Look at the answer. What's 1 plus 1 plus 7? 9. This works for every number to infinity. I can't explain why nobody's talking about it, but I do know it took me a couple years to figure out that there's a purpose for this pattern. It's just not a cool trick. There's a purpose for this pattern. Just humor me. What's 1 plus 1? 2. Prove it to me. How would you prove to me 1 plus 1 is 2? If I'm a little 9-year-old kid, how would you prove it to me? Instead of having me memorize it, oh, there we go, you got 2 cups. So you have 1 cup and 1 cup, you put them together, you have 2 cups. So you're counting objects, right? So counting objects is the way that we prove or check our arithmetic. But if I have to do 86 plus 47, that's a lot of cups to count. So other than counting objects, how else could I prove that 1 plus 1 is 2? Anybody?
11 minus 2.
That's where we're going. Look at the number 11. The number 11 is designed to teach all of us 1 plus 1. There's a 1 and a 1. We've memorized it as 2, but now we can check it. What's 11 minus 2? 9. If you get 9, everything is fine. It's a checker for the human brain to learn math facts. So let's see what happens if you make a mistake. Start at 11. You're doing 1 plus 1. You had a long week. You think 1 plus 1 is 3. Let's plug it in. What's 11 take away 3? It's not 9, so that's the wrong answer. Only the right answer will fit here to make this go down to 9. If you want your kid to learn 2 plus 2, just have them start at 22. They've memorized it's 4, but now they can check it. 22 minus 4 is 18. If the answer adds up to 9, everything is fine. This is a simple exercise that I believe will help children tap into this language of numbers, the most powerful language on the planet Earth. And my goal is to reach every kid before they're 9 years old. So when they're 9 years old, whether you take them, you got them in the back of the car driving to school and you got a speed limit sign, make it go back to 9. You take them to a baseball game and a player runs across the field, number 23, 2 and 3 is 5, 23 minus 5 is 18, 1 and 8 is 9. It's a simple mental exercise that not only teaches them their basic math facts, but more importantly, they don't need you. They don't need their teacher to check this. They get 9, they know that it's okay. So it gives them a sense of confidence, inner confidence, and it helps eliminate this anxiety that a lot of kids have with numbers because they're just memorizing all these math facts. And it really doesn't come together until much later in life. So is everybody cool with the 9 thing? Yeah. Everybody get it? So let's just try one number. I'm not going to say anything, just try it on your own, then we'll do it together. Let's do that. Shout it out when you get to the near the end. What do you do?
-6.
Take 6. What do you get? 216 equals 9. I don't know why nobody's talking about this. I don't know why it's not being taught in schools, but I really believe this simple exercise will help our kids become number crunchers, become good with basic math. And so I've been trying to sell this to schools for years, and it hasn't gone well because they have curriculum, they get paid to do it. It's a very fine line on how to sneak stuff in there. And so I came up with something a little bit different. I was home that night after Alice and I were playing golf that day, and I was writing down 0 through 9, 0 through 9. How come everything is 1 through 10? It should be 0 through 9. And so I just started writing 0 through 9 over and over again. Look at the white numbers on this screen, and you'll see that it's just 0 through 9 going across. Can you see the white numbers going across? But look at the blue numbers, and you'll see that it's 0 through 9 going down over and over again. And so this number grid is just 0 to 99, and I picked 10 digits, 10 colors for the 10 digits, and watch what happens. If you give a kid 10 crayons in this coloring book, it will change the relationship with numbers. This first page, all they got to do is find all the zeros. So you can see the zeros are the numbers that start with 0 and end with 0. The next page, you just got to find all the 1s. And all the numbers that start with 1, the 10s, and all the numbers that end in 1. And you'll see that all these beautiful patterns start to erupt off of here, all the 3s, the 4s. Every number reveals a plus sign or a cross. And when you do them all together, focus on the number 44 in the middle of that picture. And can you follow the green 4s in both directions? Do you see the green cross still? If you go to 55, you can see the orange plus sign. Every number has this symmetry to it that doesn't happen with the number chart that's in every classroom in America and around the world, which is a 1 through 100 chart. There's no symmetry. There's no patterns that the kids can learn from. So I was just sitting there and I started playing with this. I won't take you through the whole thing. There's 200 patterns I've discovered. But this next chapter teaches kids all their addition facts. This page, they have to find all the numbers whose 2 digits add up to 0. The only number that works is 00. The next page, they have to find all the numbers whose 2 digits add up to 1. The numbers that work are 1 and 10 because 0 plus 1 and 1 plus 0. Here's all the ways to make 2. Here's all the ways to make 3. You can see there's symmetry and patterns to this. The kids, they tune into this. They get excited about it. They can see what's coming next. And so it gives them a chance to understand it instead of just memorizing it. So this is called the Mental Math Matrix. It's a coloring book. And my goal is to get it in front of every 9-year-old kid. It's been a real challenge. But we've come up with something. And then I was playing golf with Steve this year, and I just reserved the rights to a new thing. I'm launching a new event. It's coming out this year. It's called a counting bee. So you all are familiar with the National Spelling Bee. We are doing the National Counting Bee. So a spelling bee, the kids have to spell a word with letters, but with a counting bee, you have to spell the answer with numbers. All right, so do we have a brave soul that's really good at counting by 3? Anybody? Anybody brave? Count by 3? Anybody? Jeff? Thanks, buddy. You're great. Okay. But just to show you how this works, the counting bee is a little different. Everybody in the first round will count by the number 3. And we're going to count how many answers each kid gets. But nobody starts at 0. Each student gets a random starting number. So when Jeff gets up on stage, we say, okay, you're counting by 3, but you got to start at 7. So you got to do 7 plus 3 plus 3 plus 3. So you have to say 10, 13, 16, 19 as fast as you can for 15 seconds. Steve gets up on stage next and you say, okay, you got to start at 14 and count by 3. Go. He might get 15 answers or 20 answers. Some kids only get 10. But it's a counting bee. And it's a simple contest to reward and celebrate these top mathletes, these little kids that are good with numbers, but they just can't be identified. And we can identify these mathletes and get them excited, get them on the right track to STEM opportunities because these kids will be identified earlier. Right now, the kids are identified in junior high. There's an event called Math Counts, which is the largest math contest in America. And it brings in the top 300 kids that are STEM kids to Washington, D.C. for 3 days, and they compete to find the fastest mathletes. So this counting bee will supersede that. It'll be before that event. But we're going to have it for all age groups. And so I finally got this all together, and I met with Steve and Jeremy and Lee and everybody at the team here at Arizona Tech Council, and we are now collaborating on introducing, it's coming out in 3 weeks, it's called the Arizona Counting Bee. And we're going to have the first ever counting bee here in Arizona. The finals are November 8th at Mesa Community College. We're going to have the top 10 kids from each age group come to Mesa that day and film it and find the fastest mathletes and show the rest of the country and the world how to run a counting bee. So next year, we will have the first ever national counting bee in Phoenix, Arizona in fall of 2019. And then in 2020, we're going to have the first world counting bee, where each country will send their top 10 kids, and we'll have the world championships are going to be in Abu Dhabi in June of 2020. So that is all ready to go. Steve and his team have helped me tremendously in just getting this organized. The Mesa School District is a part of it. They're going to support us in getting to all the kids across the state. We need sponsors, and I need companies that are interested in reaching all the kids in this state from 7 to 11 years old. And I'm going to be visiting schools over the next few months. We're going to try to find these kids, get them on Good Morning Arizona, celebrate and make them little celebrities in their community, and show the rest of the country how to celebrate mathletes. So if any of you are interested, or your companies are interested, or if you know somebody who's interested, please reach out to Steve, Jeremy, or Lee, or me. My website's thehumancalculator.com. This is the National Spelling Bee, has been going on for 90 years. This was the 91st year, actually. This is going to be our 0th annual counting bee. The Arizona Counting Bee will be the 0th annual counting bee, and then we're going to spread it across the country and let each state do one and have the national finals next year in Arizona, just to remind everybody that all this started in Arizona. So I'm hoping some of you would want to be a part of that. We're going to have a lot of fun with it. And then the other thing I would ask you is this, is please, when you go back to your company, if you send me an email in a couple weeks, we'll be able to send you the directions on how to run Accounting Bee. It's very simple. It's one page. Teachers do it in their classroom. We'll find the kids. But I'm asking each tech company in Arizona to run Accounting Bee in your company and find your fastest math lead. And please send them to the championships in November. We're going to ask for all the Arizona Tech Council teams, the companies that are involved, to find one person and send them to this. And we're going to take the top 10 of those and have them fight it off on November 8th in Mesa. So please consider finding your fastest math lead, sending us an email with who that person is, and we'll take those top scores, we'll show you how to do that, and we'll bring them into Mesa in November, okay? So is everybody cool with the Accounting Bee? Are you guys excited about it? Is anybody? Oh, thank you. Oh, just thank you again. Thank you. It's so surreal. I can't believe nobody ever came up when I submitted this for a trademark. My attorney goes, "You're never going to get it. This is too generic, no way." It took us years, and now we just finally got it. So it's really exciting, and it's sort of cool because it's not about the human calculator anymore. It's about the Accounting Bee, you know, and finding these kids around the world and celebrating them. So, okay, so now I only have a few minutes left. I wanted to share some fun stuff with you. Is that okay? Can we, Steve, are we okay? You just go like this and I'll walk off stage, buddy. Okay, all right, because I know you guys gotta go. All right, so I mentioned earlier I came up with a calendar, and I just want to share it with you because all these great tech companies, one tech company one day is gonna say, hey, maybe we should try this calendar. But just I want to throw, I'm not even tell you about my calendar yet. I just want to show you what a crazy calendar you guys are using. How many days are in a year? 365. Normally 365. How come? Why is there 365? Does anybody know? That's how long it takes the Earth to go around the sun. So we didn't come up with that. We're just following the lead of nature, 365. So we came up with a calendar that has 12 months. Some months have 28, 29, 30, 31. You never know. It's just like lottery. You see what happens next. How do you guys remember how many days are in each month? The knuckle. Don't you? It's 2018, and we're memorizing it with knuckles. This is caveman material. So our calendar's a mess. It was invented by a bunch of guys and girls 2,000 years ago who thought the Earth was flat and that they were the center of the universe. And we've learned a lot since then. Well, this all transpired in '99 because I took a year off and studied the number 0, which seems odd to study nothing for a year. Seriously, there's a lot to learn, I mean, I didn't realize 0 had so much going on. And so, I don't know, it's just sort of woke my brain up to thinking about this. And I was visiting a school on Cinco de Mayo in '99, and a little girl asked me to do my Guinness World Record and count by the number 28. So I'm going, okay, 28, 56, 84, 112, 140, 168, 196, 224, 252, 280, 308, 336, 364. And I heard myself say 364, and I was like, wow, that's almost a year. So 28 times 13 is 364. I was like, why don't we have a calendar with 13 months, and every month has 28 days. 28 days is 4 weeks. Every month would be the exact same. The 1st would always be a Monday, the 5th would always be a Friday, the 22nd is always Monday, the 28th is always a Sunday. Every number would be the same day of the week, every month of every year. It would make our life so much easier for scheduling logistics, paychecks, taxes, school schedules, on and on and on. A 28-day calendar would make all the difference in the world. And actually what's funny is our bodies are a 1328 time machine. The human body has 13 major joints, and our body works off a thing called a biorhythm, which is a 28-day cycle. Pregnancy cycles, lunar cycles, everything in nature is 28 to 29, and yet we use a calendar with up to 31 days in it. So there's no way we can synchronize our brains and our bodies with everything around us in nature. And so this calendar represents that 1328 time system. And so watch what happens. 13 times 28 is 364, so I'm missing a day. And I was sitting home that night, Cinco de Mayo, and I was like, okay, I got 13 months. They're numbered 0 through 12. There's actually a 0 month, a 1 month, a 2 month. 0 through 12 gives me 13 months. And then to sneak in that missing day, this 0 month has a 0 day. So the first day of the year is 0, 0, just like binary, computers, what it should be. 0, 0, and then it goes into 1328. And it makes our life so much easier. So I'm asking tech companies to consider adopting this calendar for fun on a strategic business financial level. If you ran your logistics and numbers for a calendar year and did 1328 versus the one we currently use, you will find there's all kinds of nuances in our calendar that cost us money. And this would level the playing field and make it fair for everybody. You all have employees. Sometimes people get paid on the 15th and it falls on a Sunday. Some companies don't pay till the next day, Monday. Some companies have adjusted that now, but there's these 3 weekends on average per year where everybody's paycheck goes into a bank for a weekend. Trillions of dollars sits in a bank for the weekend because the 15th fell on a Sunday. And somebody's making interest on all that money over the weekend, and then they give it to us on Monday. And so this calendar would eliminate all of those awkward weekends where it's not to our advantage. So all I'm asking you guys is a business idea is, if this calendar did nothing except save you 1% on your bottom line, how much of a difference would that make? If you're a $1 billion company, that's a lot of money. So just please consider this. If you want one, I'll send it to you for free. Just send me an email, I'll send you the calendar. The next time my calendar lines up with yours is 2023. So you've got a few years to get ready, because I need a Sunday on January 1st. It doesn't happen a lot. Okay, so any questions on the calendar? Is it easy? Everybody get it? No problem? And how many people are going to adopt it? No? All right, hey, we got a couple. All right, cool. Okay, so now, entertainment-wise, I need somebody with an iPhone. A simple iPhone, somebody I don't know. Who's got one? We already talked. Who else? Come on, who's got an iPhone? iPhone? Oh, there's one. Okay, okay, well, we already.
Yeah, Android.
All right, we're in the middle, come on. So, do you mind if I use your iPhone? And what kind is it? iPhone what? Is it a newer one, older one?
9.
Okay, I'm gonna use this one. All right, let's try this. What is your birthday?
9/25/61.
You were born on a Monday. Do you remember that?
I don't remember a thing about that.
Yeah, it was a Monday, I promise you, about 3:30. Okay, okay, so.
6:35 actually.
Oh, well, that's East Coast. Okay, so. All right, so here's your calculator. You guys can watch this. It's hard to do it up there. I'm just going to do it here. Your calculator's is 0, right? So all I want you to do is, I have to watch you, but punch in a random 3-digit number. And now hit times. Another 3-digit number. Times. Another 3-digit number. Times. Punch in 18.8. 18.8. And then hit equals. And if you look carefully, what's that answer? 9,251,000, what is it?
961.
Does anybody, you guys can see that? Does anybody recognize that number?
His birthday.
Do you recognize that number?
It's birthday.
Yeah, there you go. All right. So that's just a little it's an algorithm that I can do in my head to generate any time of any calendar date in history. I can do that. So just for fun, who has a birthday that they would remember what day they were born on, and just share it with me? Who has it? Who knows what day it was? Anybody? Nobody knows what day they were born?
Over there.
Oh, where? I didn't see anybody. Sorry. Oh yeah, go ahead. Oh, I couldn't hear that. February 2nd, 41 was on a Sunday. Do you remember that? February 2nd, 41. You turned 16 in 1957 on a Monday. You're going to turn 100 on a Friday. Okay? All right, so one more thing. I told Jeff and Steve and Lee, I want to share one thing with you guys before I close out, is you never know when somebody asks a question how it's going to change your life. And I always say, if you ask a better question, you get a better answer. My teacher wrote this problem on the board when I was in 3rd grade, and it changed my life. Can anybody tell me the answer to that? I heard it. What is it?
53.
53. So when I ask you all to add like this, do you guys all go like this? 7 plus 2 is 9, plus 1 is 10, plus 3 is 13. Write down the 3, carry the 1, 1, 2, 3, 4, plus the 1 is 5. Is that how you add?
Yeah.
That's the worst way to add. I don't know why we teach it, but our teacher showed us that, and the only problem was I wasn't paying attention. I was talking to my buddy next to me about baseball, and she busted me, and she picked me to go up to the board to do this problem. I was so stressed out, I didn't know what to do. All my buddies were in the room, and I walked up to the board, and I just said, okay, well, in my head I was like, okay, I've learned how to read left to right, so I must have to do my math. left to right. So I went over here and I said, okay, that's a 10, that's a 10, that's a 10, that's a 10. And I just started keeping a running total going down the columns backwards. So everybody help me out. What's 10 plus 10? Plus 10, plus 10. So estimation, we already know it's over 40, but let's keep going. What's 40 plus 7? 47 plus 2, 49 plus 1, 50 plus 3. Same answer, there's the answer. No carry, no nothing. So everybody try this one on your own, and just raise your hand real quick when you get the answer. Doing it left to right, like, 20, 40, like that.
And just shout it out, you can show off. Now, here's what's funny. The first thing I did in my performance today is I had Jeff up here, I added a bunch of 2-digit numbers in my head, and I said, how many of you can do that? And nobody raised your hand. But now, after just 2 examples, how many of you got that right? A lot of you. So if you'd have been learning this if you'd have learned this when you were 9 years old and been doing it for your whole life, how much easier would it be? Watch this. Try this one. Shout out the answer. You can show off.
85.
Wow, very good. 85. When I do this at schools, you can watch 2nd through 5th graders go from not even thinking they can add numbers in their head to doing this as fast as they can see it. The answer you guys just gave was faster than if I gave somebody a calculator and asked them to punch all those numbers in. It would take longer than you guys just did that left to right in your head. So watch how powerful this is. One more. Let's see if anybody get this. Steve, you ready? No pressure. $674. Very good. When you watch a bunch of little kids that think they can't do math and they're staring at the screen trying to figure out how to do that, it doesn't even matter if they get it right. Their attitude gets better, their enthusiasm goes up, they start to think they can do things. So my program is called I Count. I Count Academy is where kids are going to be able to go to training for the National Counting Bee and to increase their self-esteem by overcoming their fear of arithmetic. So between the National Counting Bee and I Count Academy, I think we're going to make a huge impact, not only in Arizona, in the schools in Arizona, but nationwide and eventually around the world. Every kid on the planet deserves to learn everything I shared with you today. So if you'd like to help us with that, please let us know. If not, if any of your companies would like to have me come perform or do a counting bee at your company, or if you have any schools in your life that are very special to you, I put on shows at schools around the world. It's about a 40-minute show. The kids have a great time. They learn some fun stuff, and I do my world record and things. So if you're interested in that, please let me know. Last thing before I go, Steve, I want to thank you and your team for stepping up and collaborating to make the counting bee a reality. I really think this is going to be an institution. It's really going to make a dramatic impact over the years. So I want to thank you for having me today. I want to thank you for your time. And all I ask is everybody that I shared with today about the 9 thing, please pick one person in your life who's around 9 years old and share with them what you learned today. And just watch what happens with the reaction and the questions they start to ask. All right. If you have any questions, please email me. If you want any of my books or videos on my website, just mention today and I'll send them to you for free. Thank you all for your time. God bless you all.